will now continue with a keynote address by Mel Kroon, the Chief Executive Officer of TenneT, the transmission system operator of the Netherlands and also parts of Germany. His talk is entitled Renewables, Demand, Renewed Energy Markets and Policy.
Miriam, dear guests, ladies and gentlemen. It's an honor to be here. As Mark Dirks, I was asked a number of months ago by Will Kling, and everybody who knew Will knows that if he asks you something like that, you couldn't refuse. So that's the reason I'm glad to be here as a contribute. It must have been heartwarming for me to hear these fantastic words in the beginning. I still remember the week when we had the ceremony saying goodbye to Will, that we had a huge power outage, the biggest since 17 years in Holland. It was like the electrons were so extremely angry that he died, that they wanted to give a signal. With Will, we lose an excellent and highly motivated colleague, which we still miss. I would have liked to call him after this outage to understand from him his views on the cause of it. TenneT, first, very shortly, because it's an international public here. Very shortly from my side, here you see a couple of figures illustrating the company. I think an EBIT, earnings before interest and tax, of 725 million, which means a bottom line of about $500 million. But the most important one is on the lower right-hand side, the grid availability. That is something we are striving for every day, to achieve this almost 100% reliability. And you as technicians know that 100% continuously is not possible. It's still a system with technique and human beings. So it's a task of every day to really achieve this high level. We're working on it. It also shows on our investments of 20 billion. And then to refer back to the nice speech of my friend Professor Belmans from Belgium. He accused me of being penny foolish, krenterig. Well, I like to remember him that perhaps this krenterigheid, penny foolishness, was the basis for this industry. You probably know the joke that copper wire was invented by two Dutchmen being very penny wise, pulling this copper wire, this copper cent, and they invented by that way the copper wire, and with that laying the basis for your industry. So penny wise can be quite a good point. But here it shows that we are not only penny wise, but we are also pound wise. We are spending 20 billion in the coming 10 years, investments which are needed for the change in energy both in Holland and in Germany. Clearly the renewable energy and the different locations this is generated ask for an investment in our grid. Here you see the grid, and with this picture you see the essence of what we have been doing over the last year. We have the vision, we strongly believe, that if you want to have an integration of renewable energy, that only will work if you really have an integrated network without borders. That was for us the reason to make the step into, for Holland, the most important market, Germany. And since then, over the last 4 years, we have been able to really create a network without any boundaries. And this is something which we certainly like to develop further with the other TSO in Germany and or towards Belgium. So therefore I welcome the word of Professor Belmans that we should strive for an integrated Benelux market. And this is a picture of what we see in 2023, and this is only based on the plans on which we are really working now. So it doesn't include possible dreams from our side of an integrated market with Belgium and Germany. But here you see it's really becoming a system where wind is integrated, where connections with other countries are being developed, with England, with Norway twice, and with Denmark. Ladies and gentlemen, I think you are extremely lucky because I often made jokes in the past with my colleagues. My background is aerospace engineering, and I made jokes with my colleagues that this branch, this sector, hardly had any innovations over the last 20 years. You build a transformer exactly on the same way as has been doing over the last 20, 30 years. But now this is changing. there is a clear demand for innovation. And I think this sector is becoming extremely attractive also for bright, new, young people. And the reason for this demand for innovation is coming from two sides. First of all, renewables. Renewables can only be integrated with innovative solutions. And the second one is perhaps even as important, the social acceptance. People are willing to see these developments of the grid happen, but only on a way which they accept. So that means that we have to look for innovations like the 380 kV cables instead of the overhead lines. Connecting wind parks 100 kilometers offshore, demanding for HVDC technology. Windtrack, a new innovative way of building overhead lines with lower electromagnetic fields. Storage clearly is a point of discussion. Demand management. But also on a more market side, the development of a complete new market design to accommodate the integration of wind and solar energy on a large scale. And the system integration, which is required for this well-functioning market with renewable energy. If you see this picture, I'd like to focus a little bit on the last one, the system integration and the market developments. Here you see a picture of 2013 and 2014, and in colors is indicated where the prices are relatively high or low. Green means relatively low prices, and dark blue means relatively high prices. The second, what is indicated here, are two figures. The first figure is an indication of whether or not the country has the same price level as the Netherlands. The second figure is whether or not it has the same price level as Germany. So clearly for Holland, the first figure is 100%. That means there's a 100% correlation with our price. But we have 29% of the time the same prices in Germany. Here you see the good news is that these countries are tending more or less in the same directions. We more often have the same prices as we see in Germany. But you also see that there are countries where there's still a totally different price setting level. Good examples are Poland and Italy. And that's remarkable because there are interconnections, for example, to Poland. If you see it over time, here's an indication of the average price on the wholesale market of these four countries, the Netherlands, Belgium, France and Germany. And here you see there's a tendency in all markets, all four markets, that the prices are decreasing. Secondly, you also see that they're getting closer to each other. So there is an integration of markets happening. But if you see over the months, there is still a fluctuation. For example, on the right-hand top side, you see how often the Netherlands and Belgium have the same prices. And you see that can go up to 100% during the summer period, but during the winter periods, it's much lower. The reason for the different prices are a number of aspects. First of all, the gas price is a relevant factor. Secondly, the coal price is a relevant factor. But perhaps even more relevant is the introduction of wind and solar energy. As wind and solar energy have marginal cost of almost zero, it's clear that as soon as you have a large proportion of wind and solar being fed in the market, it reduces sharply the price of that specific market. Germany, with the large number of photovoltaic and windmills, clearly has a lower price level. You can see that in this graph. The light blue line is the price level of Germany, which is clearly on the lower side due to the low coal price and due to the high winds and solar in Germany. But there's a difficulty with these interconnection situation. Clearly there is trade going on between the countries. And there's trade, for example, between Germany and the Netherlands, between Germany and Poland. But the remarkable thing here, and let's take the border of Germany and Poland as an example, that although we saw in one of the other slides that Poland has much higher prices than Germany, the commercial trade is extremely limited. How can it be that when there's a high price level difference, that there's still a limited number of trades going on between these two countries? And the answer is the physical flows, which of course have to have priority before you can have the commercial transactions. Here you see there's an extreme large flow of wind and solar energy from Germany going to Poland. And by that, using or misusing almost the full interconnector capacity and leaving hardly any remaining for commercial transactions. This is the tendency which we see happening now. From Germany, especially from the north, where there's a lot of generation of wind energy, there are loop flows being pushed through the Netherlands, through Belgium, through France, back into Germany in the south. And the same is happening on the eastern border. These loop flows are limiting the number of commercial transactions, and therefore these loop flows contribute to the existing price differences. This is really one of the challenges the TSOs have. How can we prevent these loop flows happening? Clearly, one of the answers is by improving the networks. One of the reasons why we are involved in Germany is that since our activity there, we are investing in the interconnection between the north of Germany and the south of Germany. By doing so, we improve the interconnectivity in Germany itself, and with that, we are reducing the loop flows both on the western side, the Netherlands, Belgium, France, and on the eastern side through Poland. What do we need for the further integration? Clearly, an improvement of the interconnectors. Storage is an important factor, and introduction of new systems like flow-based. Interconnectors is a clear story. The more interconnectors you have, the better you can accommodate the energy demand of the specific country. In the Netherlands, we have invested largely in a number of interconnectors. We have built the longest cable in the world to Norway. We have in operations a cable to the UK. We are planning again a cable to Denmark. And also on land we have 3 already existing and 1 in future connections to Germany. With Belgium we have 2, and we'd certainly like to extend that capacity. On itself, it's a good business case. It's indicated here that these DC cables have a payback of about 7 to 8 years, so it's an attractive investment. But these things have to be built. On land, the connections with the surrounding countries will also made a large step forward. In the past, the interconnector capacity was calculated between 2 countries. And that was the indication of how much commercial transactions could take place. Since a couple of weeks, we have in France, Belgium, Germany and Holland introduced a new system, flow-based market coupling. And in flow-based, the principle is slightly different. You don't calculate a specific border, what is possible capacity-wise, but you also look to the price differences. And then the system calculates which border has the highest price difference. So to take an example, if the price difference between the Netherlands and Germany is larger than France and Germany, a larger part of the capacity on the borders is added to the Netherlands-Germany border, and with that accommodating the market. This graph shows that in the blue area, that was the past system, you just had a fixed number of capacity calculated on a specific border. And the new flow-based market makes use of a linear programming model with a number of constraints coming from the grid, and with that calculating the optimal border capacity given a certain price level. You can imagine this is quite a complex exercise, because the power exchanges first have to make an estimate of the price difference between the countries, and then secondly, coming from the TSOs, they have to add the volume of the capacity in their calculations, and then finally recalculate how much the remaining price difference will be. In the 5 countries mentioned, we have achieved this cooperation together with the governments and the regulators. And if you look to the first results, they're remarkable. If you look to the period before this flow-based introduction, the prices of, again, the Netherlands, Belgium, France and Germany are indicated. And there was quite a difference between, let's say, the Netherlands and Belgium at one side and Germany and France being on a lower level. There was quite a gap. Since this flow-based calculation, and again, The system now recognizes that because there's a relatively higher prices in Belgium and the Netherlands, more capacity should be contributed to that border instead of to the French-German border. The prices are remarkably close. Sometimes it can mean that a certain country will have higher prices, but often it means that collectively in this part of Europe there's an economical wealth generated. These are the high complex market-driven systems which are a requirement for the future. This is the development we are looking into now. So in combination with real technical innovations, again, asked for public acceptance and required for system integration of renewable energy, this is the step forward which we are planning to make in this part of Europe. Thank you for your attention.